European Organization for Nuclear Research is the world's biggest physics laboratory. Situated just outside Geneva, it straddles the French-Swiss frontier. Over 9,000 people from 80 different countries come to CERN to carry out fundamental research into the nature of matter and the forces which hold matter together. For over 10 years, physicists have been discussing the design and the construction of a new particle accelerator, the Large Hadron Collider, or LHC. And now, all these discussions are turning into concrete. Construction has begun at CERN for this remarkable new research tool. The LHC, the most powerful accelerator ever designed, will be placed in an existing 27-kilometer tunnel. However, new experimental areas have to be built, and this work has now started. These huge underground chambers, which are now being excavated, will be the biggest underground halls in Europe. These halls are designed to contain enormous particle detectors. The LHC will accelerate protons to higher energies than have ever before been reached, and then collide them in the center of these huge new detectors. These collisions will recreate for a tiny instant the conditions of the Big Bang, the beginning of our universe 15 billion years ago. By studying the effects of these collisions, physicists hope to gain a greater understanding of why our universe exists and why it behaves in the way that it does. The LHC is financed by 20 European member states, but also important contributions come from other countries. For example, the USA, Japan, Canada, India, and China. The LHC is the first truly global science project. Physicists, engineers, technicians, and computer specialists from all over the world are now grouping at CERN to make this project a success. New buildings have been constructed within CERN's site to house all these scientists from so many different countries. The LHC is a project which demands contributions from many, many different fields: electronics, materials science, computing, and civil engineering. The scientific challenges are enormous, but also the civil engineering challenges are equally great. To dig the enormous new underground halls for the particle detectors, over 500,000 cubic meters of rubble has to be extracted. This is enough to fill the interior of the whole Empire State Building in New York. To build these underground halls, the shafts and the tunnel, new techniques of civil engineering have been developed and are now being used. For example, at one of the experimental areas, all the earth where the shaft is being dug has been frozen to prevent water entering into the shaft during excavation. Particle physics demands not only breakthroughs in science and knowledge, but also pushes forward new techniques in very many different fields of human work. Progress in science is often unexpected. Physicists have a clear idea of what they want to do with the LHC, but nature frequently holds surprises. One thing is sure, however, the LHC will change our vision and understanding